In this lecture, we'll be doing problem solving involving geometry. Our first example, two angles are complementary. The smaller angle is 1/4 of the measure of the larger angle. What are the measures of the two angles? The first thing we need to do is understand what this first sentence says. Two angles are complementary. That may be a term that you're not familiar with. Complementary angles add together to be 90 degrees. A similar term to complementary is supplementary. Supplementary angles add together to be 180 degrees. So the two angles that we have are complementary. That means that angle 1 plus angle 2 will equal 90 degrees. The smaller angle is 1/4 of the measure of the larger angle. We don't know necessarily which one is smaller and which one is larger, so we'll just choose one. The smaller angle is 1/4 of the measure of the larger angle. The measure of the larger angle is unknown. That will be our variable x. The smaller angle is 1/4 of that. We know that of means multiplication, so we want 1/4 times x. This gives us the equation x plus 1/4 x equals 90. Solving our equation, we see that we have like terms on the left-hand side. Remember, this is 1x. 1x plus 1/4 x. You'll need to get yourself a common denominator. When adding these fractions together, this becomes 4/4 plus 1/4, which gives us 5/4 x. 5/4 x is equal to 90. We have all our variable terms on the left, all of our constant terms on the right. Therefore, all we need to do is get rid of the coefficient of x. We'll do so by dividing by 5/4. Remember, when dividing by a fraction, you're going to multiply by the reciprocal. That gives us x is equal to 72. Now we want to go back and answer the question. The question was, what are the measures of the two angles? So far, we've only found the measure of angle 1. Angle 1 is 72 degrees. Angle 2, well, it's the complement. So 90 minus 72. Angle 2 measures 18 degrees. Our next application says a rectangular plot has been divided into two fields so that the length of one of the fields is twice the length of the other. The smaller field is a square and the larger field is a rectangle. If it takes 279 meters of fencing to enclose the entire plot and to divide it into two fields, find the dimensions of the original plot. Well, I'll start by making a rectangle. Our rectangle has been divided into two fields so that the length of one of the fields is twice the length of the other, and this smaller field is a square. So I'm going to make sure when I draw in this line to split it into two plots that one of them is going to be a square. The length of one of the fields is twice the length of the other. So the smaller one has a length of x, the larger one is twice that, so we'll call it 2x. We also know that we're going to have the same lengths on the top. The smaller plot is a square. By definition, a square has the same length and width, so that means that this side is going to be x as well, and this one, and this one. Now we have our entire diagram labeled. It takes 279 meters of fencing to enclose the entire plot and to divide it into two fields. That means the sum of all of these sides is equal to 279. I'm going to start at the top. X plus 2x plus x plus x plus x in the middle plus x plus 2x at the bottom equals 279. To solve, we want to combine our like terms. It's 3, 4, 5, 6, 7, 8, 9x is equal to 279. Solving for x, I'm going to divide by its coefficient. We end up with x is equal to 31. We want to go back and reread our original problem. They asked us to find the dimensions of the original plot. Well, the original plot is this here. So the original plot is 3x wide, or long, and 1x wide. So that means that the length is 3 times 31, which is 93 meters. And the width, that's x, 31 meters. In our last example, Melinda has to buy fertilizer for a flower garden in the shape of a right triangle. If the area of the garden is 54 feet and the base of the garden measures 9 feet, find the height of the triangular garden. I'll start by drawing my right triangle. The area is 54 square feet, and the base measures 9 feet, and we're asked to find the height. A lot of times, as soon as people hear right triangle, they think Pythagorean theorem. Remember, though, that the Pythagorean theorem relates to three sides of a right triangle. We're not looking to find all three sides of the right triangle here. They've talked to us about area. We want to work with our area formula. Area of a triangle is 1/2 the base times the height. We're going to plug into this formula, We know that our area is 54 square feet. Our base is 9. And we want to find the height. To solve for h, the first thing I'm going to do is multiply these two numbers together. Gives me 4.5 h. All my variable terms are on the right. All my constant terms are on the left. To solve for h, I need to divide by its coefficient. I get 12 to be equal to h. I want to go back, reread my question. They asked us to find the height. X represented the height. Therefore, we have found the solution. Our height is 12 feet.